Hey, good morning, Giants, and welcome back to another week. Hopefully, you guys all got to spend some time outside in the sunshine or do something active this weekend. We finally have some nice weather. I obviously wish we could still be back at school, be doing our normal things, but I will say at least the nice weather makes it a little easier to be quarantined. So, this week we're kind of going to finish up some topics on probability. Next week on Tuesday and Wednesday we'll review. Thursday will be our test to wrap up the probability chapter. And at that point we'll only have a couple weeks left, so we'll have one more topic that we'll kind of finish the year out with. All right, so several of you have done a great job with me. Dig in, okay? Finish the year strong. I know right now it can seem repetitive, it can seem a little boring. Okay, I'll do my best to make it clear to you. If you have any questions, please reach out. And just remember, I'm here to answer your questions. Let me know if you need anything. So, first thing I want to talk about, last week, several of you did a great job setting up your ratios, but you forgot to reduce. Okay, so what I mean by that is right here, it says the probability that we draw a 5. And once again, we know there's 52 total cards, so we know that'll go on the bottom, 52 of them right here. Now, the 5s, there's 1, 2, 3, 4. So we put 4 over 52. Now, if you put that, it's a decent answer, but we can do better. Okay, we can reduce that. 4 goes into both 4 and 52. It goes into 4 one time, goes into 52 13 times. So 1 over 13 is a better answer. Okay, so just try to remember that as you guys continue in this chapter. Now, the next thing I want us to talk about is the keyword and versus or. Okay, it's a small difference, but it results in a big difference in what we do. Okay, small change in the word, big difference in how we solve it. So right here, this first one, it says, find the probability that we find a club and a 4. So meaning if I pull out one random card, what's the probability that it's both a club and a 4? Now if we look, clubs are right there in that top row, 4 right here. The only one that is both a club and a 4, right there's one card, so 1 over 52. That is the only one that fits our needs. Okay, now if it says find the probability that it's club or a 4, I'll do this in a different color here. So if it's club or a 4, it could be any of these cards, because those would be clubs. It could be any of these cards, because those are 4s. Now keep in mind, and you can see it right here at the very bottom, it says the probability of A or B. So if there's the or in there, it's probability of A, so that first scenario, which in our case was a club. So that'd be 13 total cards. So 13, oops. Let me get that back. That'd be 13 over 52, okay, plus the probability right here of B, the event B. So that's 4. What's the probability that the card is a 4? There's 1, 2, 3, 4 of them. So it'd be 4 over 52. Now, keep in mind, we have to remove the probability that both of those are true, which conveniently enough, we just found to be 1 over 52. Now, if you're forgetting why we got 1 over 52, look right here, this one with the big green dot. That is both a 4 and a club. We counted it in the first one and the second one. We have double counted it. That's not good. So we have to subtract it off so we only count it one time. So now, when we add across, 52 will still be in the denominator. The numerator, 13 plus 4 is 17, minus 1 leaves us with 16 over 52. Now, just like we talked about before, we need to reduce. 4 goes into 16 4 times. It goes into 52 13 times. And we would be done. Okay? Now, let's move to this next one. And here we're dealing with percents. So far when we've done probability, we have not done a problem with percents. It's really the same. We can think of it as a fraction over, hopefully you guys know percents are out of 100. So just think of it as a fraction out of 100. So you could write it as 12 out of 100 would be that 12% right here. Or you can write it as 0.12. Okay, either one I'm fine with. Now it says 12% of 5-year-old children playing soccer and basketball. Okay, so 12% of 5-year-old children play both soccer and basketball. If we look here, we're going to go ahead and label this first one soccer. That represents the first circle. Okay, and the second circle we're going to do is basketball. Sorry, they're not really circles. Second oval. Okay, now hopefully you guys can see there's this. So basketball is right here. Soccer goes right there. So there's also this area right there that is overlapping. That has both basketball and soccer. Okay, so and right here it says 12% of 5-year-olds are both basketball and soccer. So in this part, we're going to put 0.12. Okay, now if we think about it, this is just kind of a visual to show why when we solve it, we add, and then subtract the combined part. Okay, so if we think about it now, it says 41% play soccer. So what that means, this whole blue circle, which we already, or whole blue oval, has 41%. However, 0.12 is already taken. Okay, so 0.41, we have to subtract 0.12 off, and we're left with 0.29 is left. That's how much goes over here. Okay. Now, in the same way with basketball, it's 22%, so 0.22, but 12% is already taken. 0.12 we got to subtract off. We're left with 0.10. That's what's going to go right here. Now, to figure out what percent of 5-year-olds play either basketball or soccer, we just would have to add those three numbers together. So 0.29 plus 0.12 gives us 0.41 plus 0.10 gives us 0.51 as our answer. However, an easier way, in my opinion, to do it, rather than subtract for both of them and figure out each part of the Venn diagram, instead, we can use this formula up above. So that'd be probability of A is 41%, so 0.41, okay, plus the probability of B, which is 0.22. And then we have to subtract right here the probability of both. So 0.12 is what's shared. Now, in this case, 0.41 plus 0.22 leaves to 0.63. And if we subtract that 0.12, we're left with 0.51. You can leave it like that, or you could write that as 51%. Okay, so either way we think about it, we'll get the same answer. I think that right here, this formula is the easiest way. If you want to draw a Venn diagram each time, you can. However, in my opinion, that is not the easiest method. The easiest method is to use our formula. Okay? So now, let's continue using that formula. It says there's a 75% chance of rain on Saturday, 55% chance of rain on Sunday. The chance that it rains both days is 45%. Okay, what's the probability that it will rain Saturday or Sunday? Once again, keyword here, or. Okay, it says or. So we're going to start by what's the probability just of Saturday. Okay, so that's 0.75 or 75%. And we're going to add that with the probability here of Sunday, which would be 0.55 for 55%. However, there's also a chance we already calculated that it could rain both days. We want to take that out because right now 0.75 plus 0.55, that's going to result in 1.3. It's impossible to have more than 100% chance something's going to happen. So we know something's not right about that. And so instead, if you ever get over 1, double check because something's wrong. We'll subtract off that 0.45 because that has been counted for both of those days. Okay. Now, from here, we'll get 0.85. And so if we write that now as a percent, we're going to get 85% chance that it rains sometime over the weekend, either Saturday or Sunday. Okay. Now, don't worry. Those are just random numbers I came up with. Hopefully, it looks like we're going to have some nice weather this week. Please give the problems related to this a try. Let me know if you have any questions. Okay. And have a great day.